while learning, if there are more than one bridge or there are redundant bridges in the path, it forms a closed loop, and if a closed loop is formed, the understanding um, bridge may get wrong information and will result in a loop, okay, continuous loop. So how this problem can be resolved? Okay, before that you must have studied uh, routing. So I'll be discussing routing with bridges. So how the routing is done using bridges. So I'm taking, see, you know that there are different types of routings. You have already studied different types of routing schemes. There is a fixed routing, okay, and there is a, I can say, dynamic routing, or you can say a source routing. Can you say the difference in these categories of routing? So if I am saying that fixed routing means like a path is fixed between a source and a destination, it is well decided in advance by the network administrator that if a packet has to move from this place to this place, okay, from one place to another place, how which path will be taken. Okay, so in case of any failure of the path, okay, uh, there is no way. Okay, if suppose a path fails, there is no other way to move in that case. So generally a low cost path, you have already studied Dijkstra algorithm and what the other algorithm, Bellman-Ford algorithm. So, suppose if I have a network like this, okay, this is LAN A, and I have connected a bridge 101. 101 is a serial number of a bridge. Okay, this is, and you must be clear that the bridge always interconnects LANs with similar characteristics. Similar characteristics means that the LAN using the same protocol. If it is an Ethernet LAN, it will be connecting with an Ethernet LAN only. Okay, so if I have to compare that what is fixed routing, what is dynamic routing. So if I am saying in case of a fixed routing, the path between a source 1 to source 7 is fixed, that it will move from this way. Okay, so in that way the packet will move from this way to S7, station 7, which is on LAN G. So you can see that there are different LANs, LAN A, B, C, D, E, F, G. So the stations are connected on different LANs. So how to route a packet? So routing can be fixed one, as I said. So if a fixed routing is to be used, the path will be fixed. So in case if suppose this particular bridge fails, okay, this bridge fails, then uh, the packet cannot be moved from station 1 to station 7, okay, because the path is fixed. So the path can only change So that is the disadvantage of fixed routing. And the path can only change when the topology of the network changes. So if it is presently it is bus, so if the topology changes to star or ring, then only this path from station 1 to station 7 will change, otherwise it will remain fixed. So in case if any failure occurs, then the path will be blocked and your packet will not be through. Okay, so that is a disadvantage. So this fixed routing is good, okay, when you will be implement, because the network administrator sets everything, so it's a kind of a centralized control scheme. So the network administrator prefixes the network cost, okay, prefixes the path based on the minimum cost. What is the meaning of minimum cost? Generally, when you select any path, suppose you have to come from your hometown to Ranchi, how will you select a path? There will be a, if you ask Google map will show you multiple ways to reach Ranchi. So if you are choosing one of the ways, like so that will be based on your the minimum distance. Okay, sometimes you want to prefer minimum distance. Okay, sometimes you feel that it can be no issue. Okay, so if there is a minimum distance, you can say it is a minimum cost, because the number of kilometers are less. So if you are using a taxi, you will be charged for less number of kilometers. So it can be minimum distance, but sometimes if the road is not good, then you may feel like I can go by a different path. Okay, maybe it will more in the distance will be more, but it will be more comfortable. So you choose, rather than cost, you choose more comfort. So comfort means like you may choose a higher bandwidth. Okay, you may choose a path where there is no chances of breakdown. Okay, so remember that cannot be predicted that there will not be any breakdown, but if any breakdown occurs, then your car can be repaired. So you may, so different parameters are there to define the minimum cost, not only the minimum distance, but there may be the bandwidth requirement, that the packet should come, that the buffering should not take time. So I should get higher bandwidth. I should get minimum delay. Okay, the delay should be minimum. There should not be no packet drop. Okay, no packet drop. Minimum routing uh, minimum processing time at the router. So these are the characteristics that an application can demand, and we will see how is it implemented when we talk about internet. So on a network, I can say where a number of heterogeneous networks are interconnected. So how this is done? Okay, so let us come back to this. So fixed routing, it can be implemented, it is good, but it can be implemented only, it is good only when you are implementing it in a limited area. Okay, when the network length is limited. Okay, so for smaller organizations, you can go for fixed routing. Can you say what is dynamic routing? So as per IEEE committee, it has prescribed routing with bridges. Okay, that is called fixed routing, spanning tree. So spanning tree is a kind of a dynamic routing. What do you mean by the dynamic routing? See, the path is not fixed. Moreover, based on the network conditions, okay, the current network conditions, the routing decisions can be made. A router, like, it is not a network administrator has prefixed everything. Okay, the decisions will be taken in real time, okay, based on the network conditions. Okay, whether if the network is more congested, then somebody has to slow down. Okay, that if you remember the that choke packet, if you had studied it earlier in the previous semester, that how to clear the congestion. So if the flow of packet is overwhelming the receiver, okay, how the flow is controlled. So dynamic routing, if something fails here in this part of the network, if something fails here, immediately a decision will be taken to avoid this path and choose a different path so that the packets can move. So it's a, when we are implementing on a larger networks, we do not know what will happen. Okay, which station is down, which intermediate device like router or bridge is down. So how to frame it? So in a larger networks, this dynamic routing works where with the passage of, just like I told you in the previous class, that with the passage of frames or the packets, the bridge learns. Okay, so any update, okay, suppose you suppose you and your friends have searched some route, you find some route that is maybe 10 kilometers, but once your friend is discussing with his other friends, he finds that there is another way which will only uh, cost 5 kilometers. Okay, so this is how, once he knows that we can reach by 5 kilometers, he updates all his friends that we can reach from station A to station B in 5 kilometers. So once any update, that any router finds a new path in the network to reach with minimum distance, so then the routing tables are to be updated, and once the routing tables are updated, the updated routing tables are to be shared with the other intermediate devices in the network. So once they, so that information communicates in the network, and all the intermediate devices updates their routing tables, and the routing decisions are modified based on that, right? So so this dynamic routing is an example of a spanning tree. And the source routing, is something where the source decides. Suppose station 1 is the source, station 1 will decide which path it will follow to reach station 7. It may follow this path, or which path it should follow, okay, to reach station 7. It should choose this path, or it should choose this path. Okay, so what I'm saying, that source routing, how the source will decide, because source is completely unaware that what are the intermediate devices and where exactly the destination exists. So how does it know? Can you say anything about the source routing part?
Sir, by flooding.
Not by flooding, because it's a very larger network, no. So how will it know? Flooding means it will see the consequences of flooding also. See, if it floods in the network, maybe one of the copy will definitely reach the destination. That is one case, but ultimately it will uh, congest the network, no, because your network will be congested. In, if suppose if all the nodes starts doing like this, then it may result in congestion. Okay, so what, how will you decide? Malo, you have to go to meet your new friend and you do not know uh, how to go there. तो आप पहले क्या करते हो? You call your friend, you ask, how will I come to your place? Okay, so that facility is not here because it cannot call the other fellow. So what it does, the source station send some root frames, okay, root recording frames. So those frames, once they reaches at different points, they record the roots, okay, in the network. And once, so that frame is basically destined to station 7. So that is basically a root recording frame, okay, that will reach to station 7. And while moving towards station 7, it will record all the addresses of all the intermediate devices, okay, and end users. And from once it reaches station 7 will again send a root recording frame towards S1, okay, reply back. And while going also, that frame will record all, because it is not necessary that it will choose the same path while returning. It may choose a different path, and while returning, it may go through some other path. So it will again uh, record the route while going back, and once it does that, the source will decide. Once it reaches at the source will decide that from where the frame will move from station 1 to station 7, how the frame will move in the network. So that is the source routing. Okay, source routing is basically employed in your token ring and FDDI, all those things. The source routing is done. The spanning tree, we will be discussing first the fixed routing. आपने पढ़ा है फिक्स रूटिंग पहले डेटा कम्युनिकेशन में? हाँ, बोलो आयुष, पढ़ा है ये?
सर डीकॉम के क्लास में नहीं था,
नहीं था,
पिछले सेम।
तो देखो ये एक नेटवर्क दिया हुआ है आपको, तो आप बताओ bridge has to maintain one table that is called as a routing table. So bridge has to maintain a routing table, and each bridge has to maintain a routing table, and there will be a central routing table, or the central routing matrix, we say central routing matrix at the network administrator, okay, that will have all the routes from one place to the other place. Okay, so from this overall matrix we can design this. So can you say, if I am doing it, okay, if I am doing it, how will I make this central routing matrix? So central routing matrix is made suppose I have source lens on this side. And I have destination lens. Are you clear why I am talking about central routing matrix? Central routing matrix is to be maintained by the network administrator. What it dictates? It dictates if you have to move from one LAN to the other LAN, okay, which bridge you will prefer. What will be? There will be redundant bridges. There may be a redundant bridges. So which bridge will take you with the optimum path? Okay, so that is already fixed by the network administrator. So here we have A, B, C, E. Can you say? Now you see, if I have to go from A to A, do I require any bridge when I am moving from LAN A to LAN A? Do I require any bridge?
No, sir. No, sir.
No, no. So it will be blank. When I am going from A to B, which bridge you will prefer? See, this kind of network is very simple, but generally, if in the exam or anywhere you will get a very complicated network where you will have more redundant bridges, right? Then the complexity of the network will increase, and then you have to choose the minimum path. Suppose I can say that the central routing matrix, I am saying that it should be based on minimum number of hops. Okay, means if I am choosing from station 1 to station uh, 6, let us say, so how many hops I require 1, then 2. Okay, so if it is based on minimum number of hops, or it can be based on minimum distance will be marked. Okay, we will see that how the distance will be marked. So a central routing matrix is created initially. So if I have to go from A to B, which bridge I will prefer? If there is a minimum number of hops,
101.
101, obviously. So I will prefer 101. So if I have to move from A to C, it will be
102.
102. So it's quite simple. Okay, so you can make it 102, then A to D, uh, A to D. A to D बताओ कौन सा होगा?
103.
No, it will not be 103. From LAN A, which bridge will receive the packet? Which will receive the frame?
B.
101, no?
Yes,
Be
sir.
101. Because you have to forward it. Then the 101 will forward it to on this LAN. From this LAN, then the 103 will take, and then it will forward on LAN D. Right? So always in central routing matrix, the address of the bridge is mentioned, which is immediate to the LAN. Okay, so from LAN A to LAN D, if I am going, it will be 101 only. Then A to E, A to E also 101. Okay. अच्छा, मैं चलो थोड़ा सा और कॉम्प्लेक्स कर देता हूँ उसको, मैं एक और यहाँ पे ब्रिज लगा देता हूँ और इससे इसको जोड़ देता हूँ. अब बताओ ब्रिज LAN A to LAN E कौन सा ब्रिज लोगे आप? मिनिमम नंबर ऑफ हॉप्स इज द क्राइटेरिया.
107.
See, you just see that if you are choosing with A to E जाने के लिए, if you are choosing this path, then B101 if you are giving, then how many hops it requires? 1, then 2, and it is directly in one hop it is coming to LAN E. So B107 will give you the smallest path. F जाने के लिए 102. Similarly G जाने के लिए भी 102, because if you have to go to G also, then also it is 102. So from similarly we will write for B also. If I have to go from B to A is 101, B to B 101, 103, 104, 101, 101. So like that you can make a central routing matrix. Okay. So from each source LAN, how can we reach to a particular destination LAN? Right? So we can I will write it. You can try it. You just see from LAN C, how will you go to LAN G? From LAN C, how will you go to LAN G? 106. Okay, I have just written it. Because if you see from LAN G, you are going to anywhere. Which bridge it will prefer? It will prefer 106. From LAN F, you see, it will prefer 105. Okay, so it is written like that. So once the central routing matrix is created, okay, this matrix is stored at a central point. Okay. So from this matrix, each bridge creates its own table. Suppose if I am saying for bridge 101, so what will be there in bridge 101 table? From the central routing matrix, bridge will take its own table, create its own table. So you can see that this bridge receives traffic from where? This bridge receives traffic from LAN A and from LAN B. Okay, so there will be two things from LAN A and from LAN B. So like the port numbers, I told you that it is the traffic is coming from LAN A, which port? Port number 1, and the traffic is coming from LAN B. Okay, so it is connected on these two ports. So if it is coming from LAN A, okay, so what could be the destination? Which LAN could be a destination? Destination can be it can be a destination, and it can be a next hop, next destination and next. To if it from where the packet, from where the frame is coming. So if it is coming from LAN A, the destination can be V, LAN B, LAN C, LAN D, LAN E, LAN F, LAN G. And if it is coming from LAN B, the destination can be A, C, D, E, F, G. Okay. So if the are you following? So if the traffic is coming from LAN A to LAN B, if the destination is LAN B, so what will be the next bridge? So you can see here. So where exactly, what will be the next hop? Next hop.
A.
No, if the traffic is coming from LAN A, you see where is the 101. You just see the central routing matrix. Where the 101 is coming? Here, B, D. So if you see here, if the traffic is coming from LAN A from this side, so either it will be delivered to LAN B, okay, or to LAN D. क्योंकि LAN E में जाने के लिए तो this is the shortest path, right? So the traffic will come from, if LAN A it is coming, so bridge 101 will be used to forward the packet on LAN B and for LAN D. That is what the central routing matrix says, right? So the destination will be, next hop will be B only, whether it is going for LAN D or whether it is going for LAN B, the destination will be, next hop will be the B only. Similarly, can you say for this, from if the traffic is coming from lane B, उल्टा साइड से आ रहा है, if the traffic is coming from lane B, so where it can go? Using this bridge.
C.
C में जा सकता है, A में जा सकता है. Okay, from B if it is coming, it may go to lane A or to lane C. If the minimum hop is the criterion, right? So it will go to A. The next destination will be A only. So if the destination is C, what will be the next hop? The traffic is coming from here. What will be the next hop? Next hop क्यों चाहिए? ये किसको forward कर देगा? Right? This bridge will forward to where? So what will be the next hop? In case
F
if it is
or
destination
G.
is C, the destination is C, which will be the next hop?
F or G.
F और G क्यों होंगे? The bridge 101 we are using. Okay, if the traffic is coming from this side and it is intended to be delivered to lane C, तो ये bridge 101 किसको देगा? Bridge 101 कहाँ देगा? 102. लेकिन 102 से पहले 102 तो यहाँ से कनेक्टेड है ना, ये तो इस लैन से लेगा, पहले तो इस लैन पे डिलीवर करना होगा ना इसको. This bridge will forward the packet to on this LAN, and then from this LAN the packet will be received by this bridge, okay, by seeing the address, and then based on that address it will forward to LAN C. Okay, so what will be the next hop for bridge 101? The next hop is LAN A. Following or not? You just see, from LAN B to LAN A you will be using 101, from LAN B to LAN C you will be using 101, and then from LAN B to LAN F G also the packet is to be delivered to which, what will be the next hop? A only, na? So A. So like that each bridge creates its own table, routing table. So this, अगर जैसे मान लो आपको एग्जाम में आता भी है तो you can quickly, once you draw the central routing matrix, you can quickly calculate it just by seeing कहाँ कहाँ 101 है. Okay, so suppose if I say for bridge 6, okay, bridge 106, आप बता सकते हो bridge 106 receives traffic from where? From LAN C and LAN G. Okay, so destination LAN and next hop. So if the traffic is coming from LAN C, it may go to A, B, D, E, F, G. If it is coming from destination LAN, next hop can go to A, B, C, D, E, F. Can you say what will be the, if the traffic is coming from LAN C and the destination is LAN A, okay, traffic is coming from LAN C, if the packet is coming from this side and using this bridge, can you reach LAN A if the traffic is coming from this side? हाँ?
No sir.
नहीं पहुंच सकते ना. तो आप देखो यहाँ पे से भी देख सकते हो, you can see from LAN C, okay, where exactly 106 is used? Where is used? To go to LAN G. The traffic is coming from this side, so from LAN C, okay? So that means you can go to the next hop will be LAN G. LAN G, ये bridge कहाँ forward करेगा? अगली LAN पर, अगले hop पे, right? So it will be LAN G. So next hop will be, it can go to destination station, that will be LAN F. Next hop will be G. Sorry, 106. Sorry, should be G here. बाकी और कहीं नहीं जा सकते हो आप. Then, if the traffic is coming from LAN G, okay, from this LAN, the traffic is coming. Then it can go to all other LANs. Then, how you can see from LAN G, you can reach all other LANs using this bridge. So if you are going from LAN G to LAN A, what will be the next hop? We are going from LAN G to LAN A, what will be the next hop? And the bridge packet frame is taken up by the bridge 106. Where it will deliver?
C.
C. So everywhere it will be C only. Okay, the next hop will be C only. So once you have created this routing table, okay, central routing matrix, you can create this bridge tables. Okay, so you may try it for other bridges also. Okay, so this is about the bridge table and this is about the central routing table. So fixed routing, you have understood that what is the disadvantage of fixed routing. If anything fails, it will fail. Now coming to spanning tree. ये वाला आपको क्लियर हुआ था? व्हाट इज क्लोज लूप? ये वाली प्रॉब्लम क्लियर हुई थी? एडेप्टिव लर्निंग क्लियर हुआ था और क्लोज लूप?
Yes.
It's important. Okay. So then we can directly move to spanning tree. Okay. See, as you have seen that there should not be any closed loop. Just in the previous class, I told you that if this is one LAN, again I'm saying this is LAN B. So whenever there are redundant bridges in the network, they forms a closed loop. So suppose this station transmits, okay, at time t0, and this is taken by time. This bridge takes it at time t0. This bridge also takes it at time 0, and it delivers on this LAN at time t1, and it delivers on this LAN at time t2. तो आप जानते हो कि जब ब्रिज अपनी टेबल बनाता है, आपने देखा that from LAN B, okay, there is a destination and there is a next hop. Okay, so once it forms a table, okay, and the bridge has no idea, so it is just learning from the movement of the frames. So once station transmits at time t0 and this bridge reaches the frame and it finds from the source address, because in the MAC header there will be a source address, there will be a destination address. So once it checks the destination address and source address, it knows that station 1 is on this side of this. Station 1 is on LAN B and destination is on this side, LAN A. Okay, destination is station 2. Station 2 में जाना है, and station 2 will be on this side. Okay, so it delivers the packet on this side, frame on this side, forwards the frame on this LAN A. Then at time T2, this bridge 102 also delivers the frame on this LAN A. Though station 2 receives multiple copies of the frame, that is another issue that we will discuss later, that how the duplicates are to be removed. Okay, how a duplicates can be handled. Okay, so that's a different case. So once it delivers on it, fine. Station 2 receives 2 copies, that is also fine. So once the transmission of this station, this 101, after delivering station 2 copies it, then it moves from this side, okay, and comes to this side, to this bridge, reaches to this bridge. Now once this bridge reaches the same frame, okay, which was transmitted by S1 and forwarded by bridge 101 to LAN A, and once it reaches to bridge 102, it again checks the source address and destination address. Since the frame is moving from this side, okay, since the frame is moving from this side, it will appear that the source station, station 1, exists on LAN B. Okay, so bridge 102 makes up its mind that the station 1 is on LAN B, right? So definitely the destination address he has to forward to on this LAN, right? He has to forward on this LAN. So it forwards with the same thing onto this LAN. That station 1 is on LAN B and station 2 is on LAN A. So once the transmission from 102 reaches to this bridge, so it also got confused that where exactly the station is. So this type of closed loop problem continues, that misguided the bridges. Okay, they completely misguide the bridges and leads in a closed loop situation. Okay, so this situation is not good. So how to deal with this situation? So there is a spanning tree. Okay, you must have heard in this biology that what is a spanning tree. So basically it is a graph theory. Okay, it's a graph theory. Sorry, in mathematics, not in biology. It's a graph theory. Okay, so it's a graph which has no loop. So which has no loop means if we have, suppose if we have no path over here, okay, if suppose somehow this port is blocked, this bridge is not allowed to forward anything on this LAN, or you can say this port is blocked, okay, blocked. So this cannot forward the frame on this side. So then the whole confusion will not be there. Okay, so there will not be any closed loop. It can directly the issue can be resolved. So what is a spanning tree? Spanning tree is there will be only one path between any source and destination pair. Okay, so you have to reach from one path from one LAN to another LAN. There will be only one path. Okay, so then once again, how the path will be selected? It will be based on some cost. That cost will be assigned by the network administrator. Okay, since why I said spanning tree, because in a tree topology, if you remember, okay, the signal travels in a unidirectional way from the root to the different branches, and every branch is single. Okay, there is no closed loop in the tree. So here we have a spanning tree. So first we decide what is a spanning tree, that we assign the cost to each path. Then there are multiple bridges in the network. So first of all, we have to select the root bridge. Which is the root bridge? So the selection of the root bridge is done by like every bridge in the network broadcast is ID. ID means there is a unique ID associated with the bridge. Okay, unique ID, you can say a serial number or this. So that is broadcasted by each bridge in the network, and once based on the smallest ID, the selection of the root bridge is made. So once the root bridge is selected, okay, the algorithm tries to find out the shortest path from the root bridge to all other bridges in the network. Okay, all other bridges or lanes in the network. So that will be based on the total cost from the root bridge to the destination bridge. The shortest path creates the shortest tree. And based on the spanning tree, as I said, some of the ports will be marked as blocked because there should be only a one path. So wherever you have redundant bridges, wherever you have a closed loop, somewhere some ports of the bridges are to be blocked so that there only exists a single path. Okay, no looping should be allowed. So the loops are avoided in that way using a spanning tree. So we will draw the spanning tree in the next class. Okay, how a spanning tree is drawn, what is the root bridge, what is the root path cost, all those parameters we will discuss in a spanning tree, and how it is how you can draw it a spanning tree. Okay, so I have another class now at 2:30, so I'm just leaving it. So you can try any other book. You can see in Horizon it is given, and if you have this book on local area network, okay, by William Stalling. So you can use this book also, or you can use 7th edition William Stalling. So by that, okay, the quiz will be on Thursday, okay, from 6 o'clock. I will notify it in the team also.
So
Okay,
duration?
Duration will be 20 minutes, 25 minutes, 10 questions, 10 or 20 questions. I will see. Okay.
Okay, sir. Thank you, sir.